Okay, so now that we know the difference between simple and complex propositions, which are the basis for propositional logic, we now need to think about how different words in different propositions affect the logic of the proposition. Okay, now there's a really important concept in propositional logic that really underlies everything that we're doing, okay? And they're logical operators, okay? Now, logical operators are words, we call them connective words, that express a logical connection or a logical relationship between different simple propositions, okay? So we only see logical operators in complex propositions. And recall, a complex proposition is simply a sentence with two simple atomic propositions or primitive propositions that are joined together. They're joined together by the logical operators. Okay, now some of this is going to be familiar to us because we're all language users, and we all know the basics of grammar. Okay, so these logical operators, they are operating according to rules of grammar, as we'll see. Okay, now for our purposes later on, when we learn about truth tables and natural deduction proofs, the issue of truth or falsity is going to be really important. Okay, so logical operators, when they are present in a complex proposition, they have this way of determining the truth or falsity of the sentence that contains them. Okay, so we're going to be learning about different rules, different definitions that determine the truth or falsity of propositions that contain these operator words. Okay, now what we're going to be learning about in the next few lessons is how to take logical operators as they are expressed in natural language as connective words, right? And how we can take those representations in natural language and put them into a symbolic form, okay, just using symbols, okay? And there's going to be a whole art of doing the translation from the natural language counterpart to the symbolic or propositional forms using the symbols, okay? So we need to start with then the operators themselves, how they're expressed in natural language, and how we will symbolize them, okay, using different symbols. Now, negation is a pretty simple logical operator as it's expressed in natural language, okay? So negation is typically expressed by words like no and not, okay, in natural language. So whenever we see negations present in natural language like this, it's denying that something is the case. This seems straightforwardly obvious, right? It is not the case that today is Thursday, for example, right? It's denying the truth of some simple proposition, okay? Now, in symbolic form, we use the following symbol for negation. It's the tilde. There are different ways of expressing it in different forms of logic, but for our purposes in propositional logic, we're going to use the tilde, the squiggly line. Okay, that's going to indicate that a proposition is being negated or denied. Okay, now our second operator is one that we are no doubt familiar with, conjunction. Okay, we all seen Schoolhouse Rocks. Conjunction, junction, what's your function? Conjunction, expressed using natural language, is simply a both and sentence, okay, both A and B. Okay, now conjunction symbolized when we begin doing the translations from the natural language into the propositional form is used with the dot there, okay, just the single big dot, okay, and that's going to stand in for the logical operator conjunction. Okay, now a disjunction is closely related to conjunction, but it expresses a different logical relationship in the sentence. Okay, so conjunction is expressing something as both and. Disjunction, differently, is an either or sentence. Okay, so either A or B. And for disjunction, we express the relationship between the sentence containing the disjunction with the wedge, right? A caret or a lowercase v. Right? Now, The fourth proposition that we're looking at with the logical operator is the conditional. Okay, and this one we are familiar with, no doubt too. Conditionals in natural language are expressed as if-then claims, if-then sentences. Okay, if A is the case, then B is the case. Okay, and for conditionals, we use a right-facing arrow. Okay, and it's really important that it's a right, not a left, not an up, not a down-facing arrow, because conditionals, as we will see, have a very specific logical relationship between the parts of a conditional, the if part and the then part. Okay, and we'll see that that can be tricky, but as long as we understand the basics of the conditional, we won't run into any trouble with that. Okay, so these are our 4 logical operators with their corresponding symbols. It's going to be very important that we recognize these quickly and understand how they work within a natural language sentence.